David Weindorf, your Vice President for Research and Innovation, and I want to thank everybody for joining this morning. I just want to start off by saying that part of the reason that we decided to schedule one of our research leadership discussions around safety is I want to let you know that it is one of the most important things that we do every day at the university. We do not want to have folks injured on the job or while learning. And I think one of the things that's really important for faculty to realize is students watch you all the time, right? They learn what they see amongst the faculty members. So if they see faculty members, regularly putting on the glasses and the lab coat and, operating in a safe manner, when they become professionals someday, that'll just be commonplace because that'll be what they're accustomed to. So just want to be cognizant of that in all we do every day at the university. I'm so delighted today to have a wonderful panel joining us to participate in the discussion and help guide us along. And I'd like to call on each of them to briefly introduce themselves. And then I think Dr. Walton is going to give a brief overview. And then we'll have kind of an open discussion and some questions which we guide throughout the hour. Certainly we'll be taking questions from the audience as well. So to start off, Dr. Walton, please introduce yourself.
Well, thank you so much. I'm so excited to be here doing this today. I'm very passionate about safety. So I'm Jennifer Walton. I'm the director for the Office of Laboratory and Field Safety.
Very good. Thank you so much. Kevin Russell.
Good morning. I'm Kevin Russell. I'm an industrial hygienist here in the Office of Lab and Field Safety. Thanks.
Fantastic. Thank you. Ming Liu.
Hi, everybody. This is Ming Liu. I'm a lab safety specialist. Thanks.
Okay. Excellent. Thank you. Jen Mars.
I'm Jennifer Mars. I'm the Executive Secretary for the Office of Lab and Field Safety.
Thank you so much. Tom Schultz.
Yes, also in the Office of Lab and Field Safety. I'm the Biosafety Officer, and I half-time biosafety, half-time in biology.
Fantastic. Thank you. And Danny Sinaway.
Hi, good morning, everyone. I'm Danny Sinaway. I'm the manager for risk management, environmental health and safety, and emergency management here on campus. And I am also very happy to be here with all of you this morning.
Wonderful. Well, thank you so much to the whole team, everybody, for participating. And I think to start off the hour, Dr. Walton wanted to give some slides just to kind of set the tone for the hour. And Dr. Walton, I'll hand it over to you.
Excellent. Give me just 1 second. And I just get a confirmation you're actually seeing slide 1. Is that correct, everybody? Are we good?
Yep, we're good.
Right. Thank you. Okay, so putting this together, I'm extremely excited to be here today. We have to start off with just a little bit of humor. Everything in our office deals with, all things health and safety, so sometimes we need to lighten up a bit. We want you to be safe, legal, and successful. And if you can read that, I'm not sure how clear it comes through on your screens, but my friends, as a result of our experimentation, we've just lost a dear and valued colleague. On the other hand, we've just gained a publication. I thought that was quite appropriate to kick off the short presentation. So just to be clear, on a more serious note, I'm thrilled to be here today talking about safety, which I'm very passionate about. I wish this was 8 hours long, but I think I'd likely be the only one that would enjoy that experience. So I'll try to contain myself. So we've already done the introductions, but just to show you pictorially, the Office of Laboratory and Field Safety. Sometimes people ask, what is the difference with risk management, environmental health and safety, and our office? We are very similar in some ways. They are in the business division, we're in the academic division. So we've already done our introduction, so you're familiar with our team. And then just to give you a little bit of an overview of, some routine services for OLFS. Sometimes people wonder what the heck we do all day. Sometimes we wonder the same thing, but our office is focused primarily on academic division, lab, shop, studio, field environments, and their unique hazards. And we spend quite a bit of time on the services listed there on the right. We do a lot of job safety analysis, particularly for new equipment and new processes. We do safety inspections, training, accident investigations, respirator fit testing. We do a lot of management with the medical surveillance program to make sure people are approved properly to wear a respirator, animal workers, biosafety level 3 workers. We oversee the lab coat rental program. We're proud of that program because we want to make sure we provide people with the right PPE, in particular lab coats that fit their application. We do some air monitoring and air sampling, particularly with chemicals. We oversee the space registrations for spaces that are unique in the academic division that have hazards, particularly like chemicals, lasers, so forth. So we maintain that database, and then we use that to help create the standardized door sign templates that we post throughout the building so that the sign is the same message, same template from building to building. We do ventilation testing. We write regulatory written programs that are required by law. An example is the chemical hygiene plan. So not only do we write them, but we update them routinely to make sure they're compliant with updated regulations. We do radiation surveys, leak tests, dosimetry, radioactive waste handling to be in compliance with the Nuclear Regulatory Commission license. Got a little excited there. Biomedical waste, we oversee that program as well and the state registration. We look at the biosafety cabinets and the annual certifications on those to make sure that those are current and safe. And we do some level of research protocol review to support IACUC, IRB, and IBC. So with risk management, environmental health, and safety, we only have one representative, Danny Sinoway, here today, but just real quickly, their office, I want to give a quick shout out to them because as a starting point, this is the EHS, RMEHS team. They're a very great group to work with. State of Michigan, I got to check the date right. Eagle was on site February 22nd to inspect the hazardous chemical waste program for CMU, which is one of the programs that they oversee. Largely because of the efforts of their office, we had no citations. We were very professional and prepared in the best possible way. So big kudos to this group because those inspections can be a little bit daunting. So they did a great job. So they have the director, Ben Kaufman. We have Danny Sinoway, who's the manager, who's with us today. Dan Kofed is the coordinator. He also is the hazardous waste person. Environmental Coordinator Nick Donaldson, Executive Office Specialist Janice Sager, and the Administrative Secretary Jacqueline Godley. Now this next slide, I'm going to turn it over to Danny Sinoway to chime in and narrate this particular slide so I don't misrepresent their office. So Danny, can you chime in?
Of course. Thank you so much, Jen. So again, just kind of highlighting a few of the areas that we cover. We are under a lot of different regulatory bodies. So I know we're all familiar with OSHA and MyOSHA. We're looking at general industry requirements and regulatory requirements, as well as in construction. So we do see both of those when we're here on campus, especially when we have big projects going on, big renovations. Of course, the EPA comes into play as well, like the Eagle inspection that we just had recently, and also with DOT when we're transferring or transporting hazardous chemicals across campus. So we're kind of under all of those, lots of things to take into consideration. We do a lot of safety training on an annual basis. Those are a requirement of the university. We do inspections and audits as well. We do a lot of investigations on the injuries that happen on campus and also with property damage. We manage all the emergency plans on campus. Job safety analysis is another item that we also do. And basically anything else that happens on campus and we don't really know where it falls into, we also work with Office of Lab and Field Safety to make recommendations and just find the best possible way using engineering controls or whatever that looks like for each situation. And so that's just a little bit of what we do. It's really hard to put it all on one slide, what we do, because it's so different every single day.
Excellent. Thank you. And that's what I'm saying. We could do this for an 8-hour day. And again, maybe you and I might enjoy that experience,
yes,
right?
I would be like.
Okay, so getting to some of the questions, sometimes, OLFS, EHS, how do they work together? From an administrative standpoint, we do have built-in efficiencies. We share a building file share drive, for example, if OLFS conducts air sampling in bioscience. The report gets filed on the EHS share drive. We share the online safety training platform, SAP SuccessFactors, so training records for any of the individuals on campus. So if someone attends training in EHS and OLFS, their training record is going to reflect both safety trainings. They don't have to go to two separate places to find all of the training records. We also train together as one united team. For example, the other night we had a joint training exercise meeting with Mount Pleasant Fire Department, Isabella County Hazmat team. We wanted to review the updates to the hazardous waste program response that were newly developed, to review some campus spaces. So we do train together, and we like each other. So that's a nice thing. We work together very well. We back each other up for emergency response. So there's a 24/7 call list for the university, and that has all of our names on it. So they can go down the call list. Whether something happens with a chemical for anything on campus, we can back each other that way. Back each other up that way as well. Now, from a programmatic standpoint, this is where sometimes people get a little bit confused. There is divided program ownership, but the hazards are not unique to various areas on campus. So, for example, facilities management staff, they periodically have to go into the laboratories, so they're affected by the lab safety program. Some of the machining and shops, example in engineering technology, they might need to practice lockout tagout and follow an EHS lockout tagout program. So we're not mutually exclusive, even though we have programs assigned to us to oversee and manage. We're not mutually exclusive. We support each other so we can have campus-wide compliance, if that makes sense. There's a lot of crossover of hazards across campus. So I just put this graphic in here because sometimes people wonder, well, like, how many spaces are we talking about? Currently have 402 registered lab shop studio spaces on campus. And to be registered, what that means is it is a space that has, it's either a lab shop studio that has unique hazards in it. Sometimes people say, well, it's a computer lab. Yes, that's a laboratory for campus, but we don't include that in our registration. So to make the list or to make the cut, you actually have some unique hazard in there that needs to be managed, that needs our involvement in some fashion. Okay, so setting the stage for the whole talk today about safety culture and safety is importance. We have 4 primary goals every year through our office, and we try to stick to these in how we approach anything that's a hazard. We want to look through as a department that we're preparing and educating students to be safe, responsible, marketable researchers, educators, workers employed with sharp safety skills. That's kind of a guiding principle for us, and we try to stick with that. Because that's really important. It's not, we deal primarily from, when we talk about government entities and regulations, they're primarily covering paid employees from a legal perspective. But in a university setting, obviously, somebody who's not paid volunteer or an unpaid student, we want them protected to the same level and the same degree. Okay, so that's why we want to make sure we have that mindset. We also want to make sure that our team is also looking at anticipating, recognizing, evaluating, controlling hazards so that we have safe, healthy activities environments. There's some unique things that happen year to year, and sometimes you get a little bit of whiplash of, we're doing what now? And that's really exciting. We need to make sure we're up to speed in this area. So that's what makes the job so fun and exciting. We also want to make sure we ensure compliance with regulations and best practices, because we want to make sure not only we're current with regulations, but we're also relevant. Sometimes best practices that we have now were maybe not best practices even 10 years ago. So we want to make sure that we're benchmarking with some of the more premier institutions. Obviously, private industry is much different than a university setting. But we also like to benchmark within the universities, and frankly, places like Yale, Stanford have some really outstanding programs, and we always want to make sure we're benchmarking and staying current and relevant in that as well. And then just the common sense goal of creating processes to make it easy for workers to work safely. Okay, so we don't want to just throw a ton of, vomit up a bunch of information and have at it be compliant. We also want to maybe whittle it down to something that's useful that people can take home with them to work safely. Okay, so setting the stage again about mindset. Safety in general is really all about your mindset. So for example, if you have a safety inspection checklist and you're marking off, yes, the eye wash has been flushed, I did my job for the week. It's good to always have a different mentality of, why are we doing this? Okay, it's more than just a little check mark, right? So when you're actually activating that, we want to make sure that people know that, does everybody really know how to activate it in this space? Especially the new workers, do they know how to activate it? When you look at the path, is it clear? And if they had something in their eye and they literally were blinded and had to feel their way to the eye wash, is it a clear path? Would they be able to do that with their eyes closed and not maybe knock into another hazard? So the mindset of safety is, you know, we're all kind of guilty of sometimes doing our checklist mentality, but sometimes we need to pause and say, why are we doing this? And then maybe it drives home the importance of, you know, why that item on the checklist is so important. So this is a graphic I've been using for about 2 years now. I'll probably replace it soon, but I do like it because it kind of says it all and we can all relate to it. Most of the time things go well with no accidents, but risky behavior doesn't always result in an accident. We don't always get caught by our bad decisions, okay? So, you know, I've worked in lab environments for over 30 years. I've never had a chemical splash to my face, thank goodness, but I still always wear my eye protection, right? So it's in place to minimize the impact should something happen. I drove to work today without incident, thank goodness. Technically, I did not need my seatbelt today, right? So that mentality of, you know, there's sometimes a lot of risky behavior that doesn't always catch up with you. So having said that, this is kind of the lead into the next slide. So 99% of the time in our lives and at the university in particular, things go incredibly well without incident. We don't have accidents left and right, which is a good thing, right? But when they do go wrong, sometimes they can go horribly wrong. Okay, so I'm just going to share very quickly a couple incidences at universities where, you know, things didn't go so well and it's just devastating. So this is, some of you may be aware, some of you not, but I'm going to give you a couple examples of how things can go horribly wrong. This was a chemical incident at UCLA in December of 2008. So this beautiful human being, Sherry, staff scientist, in the prime of her life, transferring T-butyllithium, syringe came apart, the chemical spilled, it's a pyrophoric. Her clothing caught on fire and she died 18 days later. A horrible, suffering, painful death of burns over her body. This was the first criminal case resulting from an academic lab accident. The DA filed charges against the University of California system and the professor for felony violations of California labor laws. And just to break it down for you, to give you some perspective, you know, sometimes people say, well, what was the fine and how did that play out? Well, California OSHA, they're an agreement state, so they have their own OSHA, same like Michigan. We have Michigan OSHA. They fined the university $31,000. So the agency cited the chemistry and the biochemistry department, and this is most important, what I want you to focus on. Lack of training, failure to document training, failing to correct unsafe lab conditions and work practices that were identified in an earlier inspection, and failing to ensure that employees wore appropriate PPE such as lab coats. That should be a little bit humbling. I know it is for me, because there's nothing really exotic about that list. I mean, that could happen, you know, those types of problems can happen at any university research environment. So, you know, sometimes you can sit back and go, oh, that's horrible. They did something horrible there. And yes, it's horrible, but yeah, you also have to internalize that and say, what can we learn from it to make sure it doesn't happen here, right? So that's one example. And then sometimes, well, it's not just chemicals that can go wrong. This is a laser incident. This happened in Colorado in 1996 in a research lab. They were using a class 3B diode laser. The exposure time was less than 1 second. Stray reflection from a 100 milliwatt diode laser was directed at the wall. An unprotected 35-year-old male technician walked into the area, was exposed into the eye, causing a retinal burn. So just literally in the blink of an eye, things can go horribly wrong and affect somebody's eyesight for the rest of their life. This one is a really unique situation with radiation. This was at Brown University in 1998, and frankly, I had to read it a few times back in the day because it's like, what? Is this true information? And yes, this did happen. There was a grad student poisoned 2 fellow students, prepared a chicken vegetable dish, laced it with iodine 125 from the lab, served it to the ex-girlfriend and roommate. What happened was the ex-girlfriend tested abnormally high on the Geiger counter survey when she entered the lab. So so this is a weird situation, but there's some good safety points in it if I can digress for a minute. So by following protocol of surveying for the iodine 125 on the way into the lab, they caught a problem. So following protocols actually helped figure out what happened. So this person tested abnormally high in the Geiger counter upon entering the lab, prompted the radiation safety personnel to investigate. So they knew something was weird because when you scan in and out in that case, why are they coming into the lab hot? That doesn't make sense. So they knew it was something not related to a lab situation. No evidence of contamination in the lab. They surveyed the home and actually found iodine 125 laced in that dish in the refrigerator. So that is a very unique situation. However, we do use radioisotopes at CMU, and people can use things in a nefarious fashion. And another incident, fieldwork incident, this was the University of Maine in 2016. So in this case, Dr. Hamilton, 50 years old, glaciologist, University of Maine, died after his snowmobile fell 100 feet into the crevasse in Antarctica. So very, very tragic. Studied the effects of climate change on the shrinking glaciers of Greenland and Antarctica. And we have to close the loop with the biohazardous incident just to be fair, because we don't want to look at one hazard class over another. This happened at Texas A&M in 2014. Scientist stuck himself with a needle while injecting a mouse that was previously infected with a recombinant strain of a bacteria that causes Lyme disease. Same researcher was bitten through a glove by the mouse, or probably a different mouse, just a week later. So those were both NIH reportable incidents. So crazy things do happen, and very unfortunate, sad things happen. So that's a lot of what our office is all about and why we're passionate about it. We want to make sure that things go smoothly, that you barely even know we're here, because no bad things happen, so you forget all about us. With this particular article, I threw this in, particularly given the audience, target audience today, and also an appeal for everybody's passion here for education. This particular quote's from the American Chemical Society from 2019. Dr. Hill, he's an expert in health and safety. And so the title of this article is Recognizing and Understanding Hazards, the Key First Step to Safety. And this is a direct quote. Employers are getting graduates who are not professionally educated in safety, not having the knowledge needed to recognize and understand hazards and assess the risks of the hazards, minimize the risks of the hazards, and prepare for emergencies, leaves graduating undergraduates with a void in learning to care for safety and a void in learning to manage safety in their future jobs. And I'm sure that hits home for everybody that's on this discussion today in the audience and in the panel, because we certainly want everybody leaving CMU not only with their education of their particular interests, but these other skills that go with it. Because employers really expect in private industry, government jobs, and so forth that you come out that, oh, you are a chemist. Well, do you have good safety education to be a safe chemist? Those are all very good marketable skills. So one last thing before we turn it over for discussion. Hopefully this helps set the stage for our discussion today. I'm just throwing this out here. I'd like to give you a sneak peek of what's coming for the next OLFS safety poster. So this is going to be the theme. Federal government agencies use this, industrial hygienists use this, health and safety folks use this. This is called the hierarchy of control. So our poster is going to be themed around this. And obviously the take-home point is that we always start, sometimes you can get tunnel vision. In our office, myself, I should, point the mirror at myself first. Sometimes we get our tunnel vision of tasks, and sometimes the easiest question is to start with, can we eliminate or substitute? Why are we sitting here trying to protect against this really high hazard? And it's like, do we really need this hazard to begin with? And if so, great, we'll start the tools to properly control the hazards. But sometimes a lot of things can be eliminated by saying, does this even make sense? If there's something to do that we can do that makes it safer, let's do that first to make a better choice. So that's gonna be the theme for the poster. So you might recognize the person on the right in the photo. Dr. Weindorf and Victoria Konieczka are the models for this safety poster. So we got to have some personalization with our safety message. So big thank you to them for agreeing to be the models for the poster. Victoria, you all know Dr. Weindorf. Victoria's a star senior in the Earth and Atmospheric Sciences Department. It's going to be great. I look forward to seeing the final design from Media Graphics. It's still in the works, but I had to share that little bit of excitement. And with that, I'll turn it back over to Dr. Weindorf.
Well, very good. Thank you so much, Jennifer, for that great overview of the different offices and programs and things that you'll handle. I think sometimes people, like you say, y'all are operating in the background and people don't know the full range of services and things that you handle. One thing that I also thought of that I would just bring up to the group is realize that we're an international campus, right? We have students and faculty members coming to our university from all over the world, and not everybody has the same background in the countries that they come from. So different countries often have different standards or practices, and they may be unfamiliar with our practices here in the United States and in Michigan. I can remember very distinctly being in a foreign country overseas as a visiting scholar, and I went to go tour a lab. And they told me, oh no, before you go in the lab, you have to take your shoes off. And I thought, oh my goodness, in America, that would never happen, right? But that was the practice there. And so that's what I'm saying, like people coming from other countries like that, they may be unfamiliar with our standards. And so we can never take anything for granted, and just make sure we're aware of that. So at this point, I want to pause for just a second and see if we have any questions from those participating in the audience. Does anybody want to put something in the chat or turn on their camera and audio and ask a question to this group before I kind of pose some panel questions? Okay, I see one from Ben Swartz. Go ahead.
Yeah. Hey, David. Hey, Jennifer. Thanks. Appreciate everything you guys do, of course. I had a question related to the education of our students in safety practices and making them marketable for employers. Obviously, they all go through safety training, but I'm wondering if CMU or maybe other universities have ever developed undergraduate courses that focus on safety and then make those required or elective courses for, say, chemistry majors, biology majors.
So this is Jennifer Walton responding, and I think the short answer is yes. I don't have that readily at my fingertips, but there are some folks that have done some really excellent, either a separate 1-credit class that they've done on safety to support particularly chemistry minors. And then certainly there's a ton of information through the American Chemical Society website, so I can put something together and send that to you.
Okay, thanks, Jennifer. Appreciate it. Looking forward to the new safety posters.
Excellent, very good. Anybody you have another question?
Yeah, I've got a question. Hi, this is Larry Lemke.
Sure.
Jen, thanks for that presentation. Danny as well. I was struck by the idea that we're not preparing our students as well as we can for what they're going to face when they get out in the job world. And I've gone through the 40-hour HAZWOPER training a couple of times. And one of the take-home messages that I gathered from that was that often the very first weeks that someone starts in a new job are the most hazardous. It's when they are the most apt to get injured or come across something that they're not prepared to deal with. So I'm wondering if there is any evidence or studies that have shown that students who are introduced to a new laboratory setting are maybe more vulnerable in the first weeks or months when they enter a lab than maybe 6 or 9 or 12 months later after they have gotten into that routine and the mentality of understanding all of the hazards that they're actually dealing with. Do we have to be particularly vigilant when someone new comes into our lab in the initial training period?
Excellent question. Who'd like to handle it? Jen, you want to jump in on that?
I can jump into it, but I would be interested in Danny Sinoway's response on this too, and maybe even Kevin Russell can pop in on this. So the short answer is yes, we need to be very vigilant, and especially the older I get, I tend to forget what it's like to be new, and you take certain things for granted. And when you're trying to learn a certain job, you're wanting to do a really nice job for your supervisor, and then there's all this other stuff on top of it. So the short answer is yes, and I don't know if there's studies directly that I can point to with labs specifically, but I know MIOSHA has studies that show those people are vulnerable. When we get the fatality listing from MIOSHA, it's a running total through the year, and they send out reports. It's very humbling. Very young people are dying on the job, and it's that greenness, if you will. So Danny, I'm going to let you jump in. I don't want to.
I agree, Dr. Lemke, with what you're saying, and I know that we get a lot of questions, especially when we have new researchers in the lab. And I know Kevin and I have worked on a few where the student actually reached out to us, and we met with them, and we kind of went through like, hey, these are the hazards. This is the proper container that you need to put that material in so we can take care of it properly and it's not causing other, hazards in the space for other people that are moving in and out of there. And we do try to offer, all of the trainings on a running annual basis. Usually every month we have something offered, if not more. And so I feel like those opportunities are available. We offer, face-to-face, HyFlex, WebEx, Teams platforms. We are offering these throughout the year, every month. And I know, we're posting those, we're getting those out there, it's getting emailed out. And I don't know if they don't understand that it's applicable to them or if maybe they're not in that group or something. I'm not really sure, but we do try to put ourselves out there and we're out in the labs, not as much as, Jen and Kevin and Ming are, but we're picking up the hazardous waste and kind of, reflecting and having those conversations like, hey, maybe try this, or can I get you a container for that? Or, so trying to be helpful and supportive in those ways. But yeah, we do offer training aside from like what Jen had mentioned. We are facilitating those trainings for PPE, hazard communication, understanding labels, and why it's important to label our contents of what we're doing. It is very important, and we find often that people are not doing it, even though they are attending training. I don't know if it's just an extra step, or maybe they don't have time. And we're constantly reminding, we're constantly helping, we're constantly bringing labels, we're constantly, hey, I need a date on this. And we're happy to do that. We're happy to do that. But at some point, I don't know if it's something that we need to mandate everybody go through, and what that looks like moving forward.
I'll just jump in and say thank you so very much for the services that you do provide. Those are essential. That training is essential. And I think you, for me at least, put your finger on it. Time is always the issue. It's the most precious resource we have. And I have to remember as an investigator to work with the people I have in my lab that I need to spend time with them, and I need to take time to discuss these things with them, as you do when you have contact with them as well. Taking that time is a great investment and a necessary investment, but it's often difficult because of the so many other conflicting demands that are put on all of us. That's something we all share. So thank you.
Very good. Thank you, Larry. We appreciate it. Go ahead, Tom, jump in here.
Yeah, I just wanted to say, I think an important tool that's in the chemical hygiene plan is one of the pages in the appendix is the lab-specific training page. And I know, the longer you work in a lab, you kind of forget to mention things to your students. And it's a nice reminder to just kind of go through and tell them where the eye wash is, where the safety shower is, what the PPE requirements are. So it kind of not only trains your student, gives you a document that you can provide, but also kind of is a good reminder for you as you work in the lab. So.
Yeah, and one thing I might add to that as well is make sure that with those types of things, the safety shower, emergency eye wash, you regularly flush those things, right? If they're never used, they could be full of corrosion and things like that. So, I try to always make it a point every couple of weeks, just turn it on for a minute, let it run into a bucket, something like that, to make sure that if an emergency use of that was needed, that it would be ready to go. So. Ming, I want to pose a question to you if I could. I know that you've been out across campus in the last few weeks and months doing some safety inspections. What can faculty members do to kind of prepare for those safety inspections ahead of your visits?
Thank you, Vice President Dr. Weindorf. Yeah, I'm happy to give a try. So, to be honest, if I'm in charge of a lab, I like to walk through the lab with the inspection checklist. When our office sent out the email to schedule an inspection, we also included the inspection checklist. And after I receive the email, I can just go ahead, walk through my lab with the checklist and in the checklist, we can see we have 7 sections and 56 items. So I can check all the items that are not applied to my lab, and check off all the items that we already meet the requirement. So just focus on the items that we need to implement the corrective actions. So to be honest, this is really a short term just to prepare for the lab safety inspection, but this is not really the purpose of the lab safety inspection. So I would like to maintain the safety and health status after the lab safety inspection, and to follow all the regulations that are related to my lab, including the chemical hygiene plan, including the bio safety manual, including the laser safety manual, and also the radiation safety manual. So I think this is the long term. This is the really a purpose for lab safety inspection. We just wanted to help to all the lab, all the PI, to maintain the long term safe and health working environment in their lab. Yeah, thanks.
Excellent. Thank you so much. I appreciate that. In kind of a related question, I'd like to point this over to Danny Sinaway. We have various governing bodies like MIOSHA who might show up and do some sort of an inspection in the lab, right? If they come to campus, if they show up in a lab, what does a faculty member need to do? Who do they need to contact, if anybody, to let them know about that?
Of course, thank you. Yes, so interestingly, we kind of have like two instances most times, and I'll say 99% of the time, when MIOSHA shows up on campus, it's not a planned event. It's definitely a surprise. And so I would just let the faculty or whoever the person is, it could be, a student, they need to let the Office of Environmental Health and Safety know. And I am the lucky individual that gets to be the liaison between the university and that inspector. And just so you guys have an idea of what is expected of our office and of me, is I need to drop what I'm doing and be there in 10 minutes or less. That's how serious we take the inspector on campus, because we like to be with them when they're walking through the spaces and the areas. And if I need to contact any of the people of the lab spaces or any of the other people working in those areas, I need to be able to do that quickly. And I would definitely be contacting Jen's group if it was in a lab space, and asking for their support on that as well. There are other times, like the most recent Eagle visit, where we actually had a little bit of time. They actually scheduled the visit with our university. So we had a little bit of time to put some paperwork together and get those documents ready for them. So when they did arrive on campus, we were able to present them to them and go through all of that information. But then again, we're going through lab spaces, we're walking through areas where, research is happening, where we have hazardous waste locations. And so it's a very involved process. There's a lot of follow-up and a lot of communication that happens between us and those regulatory agencies.
Thank you so much for that. Yeah, I can remember when I was a faculty member at Texas Tech University, my lab was regularly inspected by USDA because I had foreign soil that coming in, foreign soil APHIS permits. So they would have to come through and check and make sure we had everything properly secured. So I want to shift gears just a little bit and pose a question to Kevin Russell, if I could. He's our industrial hygienist. Talk about, you're an industrial hygienist. Talk a little bit about the importance of that for something like respiration, right? Maybe there's a recommendation that you might need to wear some sort of respiratory protection when you're dealing with animals or handling them in a certain way. And if you don't do that, you could face some pretty serious consequences. I mean, maybe talk to that a little bit.
Sure, thank you. With animal use, if you have a personal history of allergies to maybe cats or dogs or things like that, and now you're going to work with mice or rats, they're known to have very allergenic proteins in the dander, the waste products in the bedding and things like that. So throughout your career, as you're getting this exposure, you can really develop severe allergies that could eliminate your option to work with animals, or even into like a debilitating asthma situation where it just progresses because of that repeated exposure. So really our hope is to keep everyone safe and to keep them healthy, and especially our student workers and researchers. They're just starting their careers, so it would be horrible to invest your time and energies into a degree that now 5 years later, my allergies are so bad, I can't work in my field. So I know that they're not the most comfortable things. Most our office staff and EHS as well, we're fit tested for full face respirators. They're not comfortable. N95s, I recently did some of the speech therapy students because of COVID protocols, and they were very surprised how tight they are. And one kept pulling the straps, and I'm like, they're not going to stretch. They're meant to be tight. And I do think COVID kind of helped the respiratory protection world. A lot of people became very, informed about respiratory protection. So and here at the university as well, the animal facilities are accredited, and to maintain that accreditation, the occupational health is a critical component, as you know, and Jennifer knows, and we're working through that to meet those regulations. So it's just one of those things. It's like with all exposures to chemicals or radiation or thing, a little bit every day can add up to, a lifetime of concern or issues. So I like to keep everyone safe.
That's great. Yeah, it's kind of that chronic exposure that we don't always think about. We tend to focus a lot on acute effects, right? When there's a spill or you inhale something, but those lower dose chronic effects can be equally debilitating and are important to consider. Jen Mars, let me ask you a question. We have summer coming up. We're going to have various students coming in here, potentially visiting scholars coming from other locations. Is it possible for us to get them some online safety training, and how would they go about that?
Yes, it is. Actually, the first thing they would need in order to take our online lab safety training is to get a guest CMU Global ID. So that's done through OIT, and the easiest way is just to contact our office through email or phone, and we can get the ball rolling. I would gather information on the visiting scholar, basics. They need driver's license and different things like that. And then I submit the ticket, and once they receive their guest user ID, they will be contacted by OIT, and then from there, we just follow the usual protocol that we have when you have, people that need training in your lab. You fill out the lab safety training form that indicates the required training for that specific lab.
Yeah.
Yeah.
And I guess there's different modules that they may take related to their specific area of studies.
Right. And then submit that like you normally would to get them started with success factors. So there's on our training webpage, there's a link where they can go and submit, once they have their ID, submit a user access form, and then we get contacted, and then I'll assign the training, and they're all set. So yeah, just contact us first, and then I can get that going.
Sounds great. Thank you so much. Let me again pause right here and see if we have any questions from those on the line. Anyone want to raise a hand, put something in the chat, turn on their video real quick, and ask a question of our distinguished panel? We had some good questions earlier. Dr. Lemke and Dr. Schwartz, they were bringing their A game. All right, well, I'm going to forge ahead fearlessly then. Again, if people have questions, just put those in the chat. Tom, my next question is for you. What are 3 biosafety guidelines commonly overlooked by researchers, even if they have years of research experience?
Well, thank you, David, for that question. Part of my job is to do risk assessments of new protocols that are submitted into research compliance. And so I go into these lab spaces, and luckily at CMU, we have some very dedicated and capable individuals working in these research spaces. But oftentimes there's little things that are overlooked in regard to biosafety. One that I see quite often is not having biohazard stickers on the equipment that may have materials that are potentially biohazardous. So things like freezers where samples are stored, biosafety cabinets where work is being done, refrigerators, those kind of anything that really is exposed to a biohazardous material should have a biohazard sticker on it. And it's just an awareness thing for everybody in the lab, not to be touching things. You don't go up and lick the freezer because there's a biohazard sticker on there, you know. Another thing that I see pretty commonly, and this gets complicated, we had a meeting earlier on sharps protocols, and any sharps that are contaminated with biological materials need to go into a sharps container with a biohazard label. And what's often overlooked is, you know, through the state of Michigan, which regulates most of the waste protocols, is that they need to be discarded within 90 days. And it's not a real big deal, except a lot of times people buy these big giant sharps containers and they'll have one needle or one syringe in there, and they'll have to get rid of it within 90 days. We have Stericycle pick up our sharps materials, so I mean, it's the easy process to get rid of, but research should probably consider the size of the sharps container when they're purchasing those, realizing they're going to have to be discarded once they start filling them 90 days later. And then the last thing I notice is oftentimes they don't have, and Ming mentioned this earlier, is a biosafety manual. And I have one available, which is a generic version, which if I go in and audit a lab or talk to researchers, I'm welcome to provide, I'll provide that to them. And it gives them just kind of general biosafety information. And it's kind of got a list of things that they can add to that manual, training documents, regulations, SOPs, SDS sheets, all of those things that can go in there. But the CDC requires that the guidelines say, they don't require it, but guidelines say you should have a biosafety manual if you're working with biological materials.
Excellent. As a follow-up to that, I want to mention a different type of sharps that we often may not think about, and that's kind of broken or cracked glassware. Even if it doesn't have any potential contaminants on it, it might be clean. But you know, if you're working with a cylinder or an Erlenmeyer flask or something, and it has a crack in it, it's really best to just discard of that. I mean, you don't want that to break when it has chemicals in it or it's being heated or manipulated somehow. Jen Walton, I mean, I guess we have typically specialized boxes that we would put that broken glassware in various labs.
So that's a good follow-up question. So, and frankly, looking over the years, some of our more serious lab accidents at CMU have been glassware related, where either glassware shattered, broke, there's been laceration, some of them quite serious, requiring stitches. So glassware is not something to be taken lightly. So the answer, yes. How our chemical hygiene plan is stated, they're not supposed to put broken glass in the regular trash because we want to protect the custodial staff. And just as a sidebar to the audience so that they're aware, when we do the awareness training for the custodians, we make it very clear to them, if they go to pick up the trash and there's either a syringe that accidentally got placed in there, broken glassware, or something that doesn't look right, we instruct them to just leave it, not pick it up, contact our offices, and we will help make it right to make sure that they're safe so the trash just doesn't get picked up. We don't expect them to handle that. So they just put it on pause, walk away till we can assess what's going on. So we do have, the requirement is we typically have the cardboard boxes that have the glass trash clearly labeled on them. As long as they have a poly liner in them, then you gooseneck it, tape it up, and then tape up the box, and that goes directly to the dumpster.
Yep. Excellent. Thank you so much. Another type of disposal that, you know, we don't think about sometimes as researchers, you know, we order some chemicals, we're working down in the lab, 5 years goes by, that chemical's always been sitting there on the lab, and we forget, oh, it expired, right? And, you know, sometimes as a faculty member, you're hesitant to want to throw that away because you think, I can still use it, right? I've always been one to say we've got to dispose of that properly, right? You don't want to be conducting experiments with expired chemicals because you can't reliably count on those results from the experiments anyway, right? Beyond that, there's all kinds of safety concerns for chemicals that could degrade over time. So, Danny, let me pose the question to you. If faculty members have expired chemicals or hazardous waste that they need to dispose of, what's the proper way to go about getting rid of all that here at CMU?
Thank you for that question. In fact, our teams were just discussing this this past few weeks. So honestly, the best way, and I'll tell you, is to go to our website. We actually have a link, and you fill out the form, basically kind of stating what the waste is, where it's originating from, and that is basically sent right to Dan Kofed, who is in our office. And basically, we take that paper and we go to the location where the content is, and we pick it up and we take care of it. I do want to add though with this that it needs to be labeled properly. So we will not pick up anything that is not labeled properly. And if that person or whoever started, you know, the waste, we can help them with that. We can bring them labels. We will help them fill it out so it's done properly. We have all that, and all of that is on our website too. So if they wanted to print their own label to get it started, because once you start accumulating, you need to have a label on that, and that's really important. A lot of people don't realize that. And so it's very easy. We make the process as easy as possible. We pick it up and it just goes away, right?
Mm-hmm.
But it is stored on site. And of course, we have a 90-day and it's picked up by one of our contractors. So that goes through our office, and our teams both work together on this. So it's quite a process, but we try to make it as easy as possible. And if the researchers or the students have any questions about how that works, we meet with them. We make sure that they have the right container for whatever they're disposing of. I know compatibility has been an issue in the past, and so we just want to make sure that they're using the right things. And even if we order it and give that to them, we do that as well.
Excellent, thank you. And I'd like to point out also, it's important to remember this disposal of chemicals and leftover samples and things, especially when we have people leaving the university. So if we have graduate students who've been working on a project for 2 or 3 years and they have some stuff, we don't want to just leave it there and then they leave and go elsewhere, and a few more years go by and nobody can remember what was in that container or where those samples have been. This is also really important if we have faculty members who retire or leave the university. Before they walk away and we don't know how to contact them anymore, make sure we walk through the laboratory with them, identify all of those wastes that can be disposed of in a proper way. One other thing I want to point out real quickly is perception is reality. And I kind of touched on this earlier where we were talking about the idea that students are watching us all the time. It's important when we walk through the lab that we have the lab coat on and we have the safety glasses on. Another thing to think about is we all want to promote the work that's going on in our lab, and that's a very healthy and good thing. But we need to always be thinking about the photos that we take. Sometimes we see different publications or something put up on a website at the university where somebody would just happen to be in a lab and, oh, this is really cool, let me get a photo of this real quick. And if the people in that photograph are not wearing the glasses and operating in a safe manner, and then that gets out on our website, that can be a really bad look for the university. So these are things that Dr. Walton's office is constantly working with university communications to make sure that the image that we portray of CMU is always the best one possible. So just keep that in mind as you're grabbing snapshots, either in the laboratory or in the field as well. So I'd like to give Dr. Walton the last word here and just pose this kind of question about what do CMU researchers, instructors, and staff do that make them positive safety role models for our campus?
Okay, so one of the things, I guess in a nutshell, to summarize a lot of the different talking points that we've had today, these people not only follow the rules, they understand the why, and then they pass on that importance and that education to their students. It's the example I gave about with the eye wash. It's not just that you're doing it, but why are you doing it? And that makes it a little bit different flavor. They integrate safety into their lab meetings. They integrate safety into their course instruction. They wear the required PPE, as you had already mentioned, whether they're in a lab, a shop, a studio, the field environment, whatever is the required PPE. These folks not only expect it of their students, but they model it themselves, as you already pointed out. They also set the expectations for safety, and then they enforce that behavior. So, and when I say enforce, that can be a tough word to use, but they expect it. And if you're going to get some gentle reminders, and then there's going to be some steps if people fail to comply. So they set the standard, they enforce the behavior, they self-inspect, as Ming had pointed out earlier. When they identify a safety violation, they fix it. You know, and so just to summarize it in plain terms, one of the functions of OLFS is we routinely conduct routine safety inspections. We give notice of the inspection, as Ming pointed out. We share the checklist. We outline the scope of inspection at least 2 weeks prior. And so to drive this home, some faculty will do nothing to prepare, to be frank. And then we have a lot to write down. Some people are going to prepare for the inspection. They close out all the violations, fix everything, but then they start backsliding the moment we walk out the door. But the ones that are the good safety role models, these are the folks, getting back to your question. Some faculty are safety role models. They prepare for the inspection. They get their lab workers involved in that, and it's a discussion, and they all are in it as a team to prepare because they all have ownership of it. When they are cited with a violation, and frankly, nobody's perfect, so we expect we're not going to have perfection, but if they do find something that's not quite right, they not only correct the deficiency, but they incorporated the solution into their operations moving forward so it's avoided in the future. So kind of a long-winded answer, but you know, none of us in OLFS or RMHS expect perfection because we are not perfect people ourselves. It can be very humbling, you know. So
we're all always learning. That's right.
That's right. So we always just try to give a gentle reminder. And, you know, like I have prescription lenses. So sometimes I've told Ming and Kevin, I said, if you ever see me, sometimes give me a gentle nudge. I may be holding my safety glasses because I feel them and I forget, you know. So, you know, you just give the gentle reminders and we're all in it together.
Thank you so much. And I just want to point out one other thing. We haven't talked too much today about field safety, but as we approach summer, don't discount that as well. You know, biting insects, wasps that might be out there, turning an ankle, you know, I mean, there's all sorts of dangers that you can face depending on where you're going. Out in West Texas, we always used to watch out for snakes, you know, when we're walking across the rangeland. So just things like that, I mean, to think about depending on where you're going to be conducting your research in the field, heat stroke, those things as well. So I want to thank all of our panelists today, Tom, Jennifer, Danny, Ming, Kevin, Jen, Mars. Thanks to all of you for a really outstanding overview of this and for setting the leadership standard in terms of safety across the university. This is really important to us. It's important to me as vice president. It's important to all of our faculty members and students here to keep all of us safe. So I want to thank all of you for your time today and presenting this to us. Anybody in the audience who has additional questions, feel free to reach out to our panelists. I'm sure they'd be glad to answer more questions offline or even meet with you to answer your specific questions. And as we approach the end of our session today, I'll just mention our other research leadership discussions we have upcoming. Our next one is going to be on research computing on Friday, April 22nd, and we'll be talking about research computing resources that we have across campus. And then I'm in the early stages of planning 3 for this fall. One on graduate student research leadership discussion where they can ask the questions that they like. Another one focused on library resources. Dean Irwin, I'll be reaching out to you about that. And then I have one entitled Everything You Ever Wanted to Know About Research Compliance But Were Afraid to Ask. So we'll see if we can get somebody from IRB, IACUC, IBC to come and talk with us about some questions there. So thanks to everyone for joining today. I hope you have a great, wonderful weekend and be safe out there. Take care, everyone. Bye-bye.